Hello, my name is David Giles and I work for Hightex UK Limited. This is a short presentation on the 10 coding commandments. This presentation is aimed at those customers who are looking to improve the overall quality of the software which they write. With my extensive experience of talking to software developers over the years, I've compiled a list of 10 things which engineers should be doing in order to improve the overall quality of the software which they write. Please feel free to take on board some of the ideas which I have within this presentation. This presentation is designed to highlight some of the key topics which are very important if you're looking to write stable software. These 10 areas I've broken down into commandments, and each commandment indicates an area that requires investigation by a software team in order for them to produce software that is reliable. Coding Commandment number 1 indicates that a software plan is required. The product requirements should be clearly defined in a document that is available to all members of the software team. The product requirements documents should be broken down into software requirements, and the software requirements should be subdivided down into some kind of software architectural model, which can then lead on to a detailed design specification for that module itself. And what I mean by a module is a C-source function or a collection of functions that perform a specific task. Each detailed design spec can then be coded by a member of the software team. And each of these modules should have defined functionality such that the documents can be given to both a test engineer and a design engineer. The test engineer can independently develop test vectors for that function independent of the software code writer. Now, this is what should happen in an ideal world, and many companies will do this in some part. Generally, companies will have a product requirements definition which originates from the marketing department, and quite often this will get broken down into software requirements. However, very few companies actually break that down right the way down into the C function level. So quite often we see customers having some definition for the product in marketing, and also some software requirement specification as well. Requirements capture encompasses many of these aspects, and if you're writing software for a high integrity application, it's absolutely mandatory that you have some kind of capture tool to enable you to do this successfully. And I've detailed on this presentation here the names of 4 such tools which I've seen in my observations as an embedded firmware engineer. Moving on to Coding Commandment number 2. An in-house coding standard should be adopted for the development of a project. The coding standard should be available to view, and it should be archived along with all the other related documents. Basic standards such as MISRA 98, MISRA 2004 and the ANSI standard should be used as a basis for the in-house standard. The in-house standard should encompass naming convention and coding styles also, in addition to items from MISRA 98 and MISRA 2004. Version control. A version control system should be used to manage documents such as software files, header files, specifications, software plans, house coding standards, etc. So these documents which are important to the company should be checked in and checked out of a version control system, such that there's some traceability within the standards which they're working to. So these documents which are important to any project should be checked in and checked out from a version control system as and when they are being used or modified. Coding Commandment number 4. Any C source code that you write should be checked by a static analyzer tool. The analyzer should be used to check the rules as indicated by the in-house coding standard where possible. At Hightex we sell 2 static analyzer tools. We sell Gimple Software's PC Lint, and we also sell Development Assistant for C. Coding Commandment number 5. Unit testing. So the C function unit testing and software integration testing should be done on your C source code. Each C function should be independently tested in complete isolation from all the other C functions with a view to achieving 100% coverage. Deviations from 100% should be detailed in a separate document indicating the reason why. In many instances, software cannot be 100% tested. Software units whose functionality depends on the correct operation of other software units should be subject to integration testing. And integration testing is where you kind of have a layered approach to software, and you don't test each function in isolation from the other one. At Hightex we sell Tessie, which is a unit testing tool from Razorcat. Peer review. A peer review process should be used for those areas of the code that may not lend themselves to unit testing. You need to review all the code with a second pair of eyes and check for naming conventions, etc. In a larger company this is much easier to do, as there's more resource available to do this. Test strategy. The test engineer producing the test cases for the unit testing must be independent from the software code writer. The initial test cases must be generated from the documents provided, with only the function prototype initially available to the tester. This may be reviewed following the unveiling of the source code and amended to achieve 100% MCDC coverage. The reason for this is that the initial software requirements and the software architecture structure may well have been misinterpreted by the software developer. By having a test engineer here who's independent from the software writer, any ambiguity which may be present in the software requirement specification will be identified. Quite often the test engineer is the person who produces the test cases. However, the test execution and the unit testing can actually be done by the software writer, but it's important to have an independent person within the loop to verify that the software requirements have not been misinterpreted. Functional test execution. This is where the complete system itself is fully exercised with the complete object code present in the system, and it's exercised in accordance with its normal operation. The test must include typical scenarios that the product must see under fault condition. The testing scenarios must be documented and the test results archived for future reference. And again, most customers generally do this. Once the product has finished, there's some form of testing which has gone in to that product prior to shipping the product. Tool qualification. Each of the C compilers and test tools must have a tool qualification pack available for it. For C compilers, it is expected that the tools have been validated by a third-party tool suite, such as a Plumhall validation suite, and a statement of conformance be available for inspection. For test tools, it is expected that the manufacturers provide a tool qualification pack. In the case of unit testing and static analysis testing, this TQP should be suitable for the embedded target microcontroller that is being used. And the final one, Coding Commandment number 10, the product must be field trialed for a reasonable period prior to shipping the first production units. So for each of these coding commandments that you are compliant with, you can score yourself 1 point. So for example, if you do static analysis testing, if you have version control, and you have software requirements capture at the front end, then you would score 3 points, one for each of those items which I've just described. And what this means is that it allows you for the first time to put a score against your product. So for example, if you're developing anti-lock braking systems for cars, or if you're developing an actuator for an avionics application, my expectation is that you should be scoring an absolute minimum of 9 and ideally 10 for your product. However, if you're designing something like a coffee grinder, then it's not so important, for example, that you have a tool qualification pack. It's maybe not so important that you're doing unit testing on your software. So in this case, my expectation would be that you would have a score of somewhere between 6 and 7, and it's not unacceptable for you to have a score of 10. So not all projects will require you to score 10 on this Giloscale. However, if you design a product and that product goes out into the field and you've only scored 4 points on the Giloscale, and if that product then subsequently fails due to software problems, then you can't really be surprised, as you've not really put any real effort into ensuring that you have no software bugs within your code. However, if you was to score 10 and your product was to fail, then you have indeed been unlucky, because you have spent a lot of time and effort in trying to resolve the bugs that are present in your system. So ask yourself now, how easy is it to move up 1 point on the Giloscale? So look back through each of the 10 coding commandments and identify one which would be very easy for you to achieve that you're not currently achieving. So for example, static analysis testing. If you're not currently doing static analysis testing, you can buy a static analysis tester for something like £250. And it has a very small learning curve, so to actually score one extra point doesn't create too many problems internally within your company. It's not time consuming and it's not expensive, so really you have no reason to not do that. If your product is not safety critical, there's a trade-off between man hours of effort and software reliability. So you have to take a subjective view as to which of these items on the Giloscale that you want to be compliant with. But if you're in a company that, for example, doesn't have any form of quality measure on software, by adopting the Giloscale you can decide at the first point in a project as to which of these items that you want to be compliant with. So for example, if you're doing an application maybe not so safety critical, but nevertheless you want to have some good process in place, you can decide to have requirements capture, you can decide to have static analysis testing, you can decide to have version control, and that would be adequate for your project. So you can decide this before you start, and as part of your internal quality review meetings you can decide whether that's acceptable for your particular product and application or not. So the Giloscale for the first time gives you the ability to grade a product. Okay, so for a more detailed explanation of the Giloscale and the 10 coding commandments, please send me an email, dgiles@hitex.co.uk, put 10 coding commandments or 10cc in the subject box, and we'll email you in return a self-assessment form which details each of these 10 coding commandments. There'll also be a detailed explanation of each of those commandments as well, and you can use this as a basis for internal discussion within your companies. Thank you.